Yeah, good morning, students. Welcome to this CAO class. So, in the previous classroom discussion, we had the discussion on different types of representation of these memory words like Big Indian and Little Indian method of representation. Now, in today, we would like to discuss on what are the different types of instructions and how the instruction execution sequence is there in executing the different types of machine instructions, that is instruction and instruction execution sequence we would like to discuss in today's session. Now I would like to share my PPT. So instructions and instruction sequencing is the today's topic for discussion. So the learning objectives of today's session are: this session will develop the knowledge on instructions and instruction execution sequence, and register transfer notation, assembly language notation. These are the two important notations which are used in representing of these instructions. RISC and CISC instruction set we will see, and we will give some introduction to RISC instruction set. So these are the objectives of today's session. So what is an instruction? So instruction is used in computers to perform certain operation. So computer must do certain operation through the instructions. So there are four different types of operations that we can perform in a computer. So the first type of operation is data transfer operation, through which we can transfer the data between the memory and the processor registers. Between the memory and the processor registers, we can perform the data transfer. And second type of operation that we can perform is the arithmetic and logic operations on the data we can perform. And the third one is program sequencing and control. So how we can perform the execution of the program and controlling the execution sequence. That is the third type of operation we can perform in a computer. And coming to this fourth operation, which is called it as the IO transfers, that is nothing but the input output operations, taking the input from the input devices and taking the displaying of the output onto the output devices. So these are the four important operations we can perform within a computer, and how these four different types of operations we can do by specifying the instructions that we are going to discuss now. So in order to understand clearly about these first two operations, that is data transfer and ALU operations on the data, so we need some sort of notations. We require some sort of notations we require to understand before we proceed for the instruction specification and instruction execution. So there are two different types of notations are there in computer organization. So the first type of notation, which we are calling it as RTL, register transfer notation. So the data when we are transforming the data when we are transforming between the memory locations and processor registers, or the registers in the IO subsystem, how we can specify this data, in what way we can specify this data, that is done in through different two different ways. One is RTN, that is a register transfer notation we can represent, and second one is in assembly language representation we can represent this data transfers we can represent. So now we are looking into this register transfer notation. So the names that represent the addresses of the memory locations. So we are taking some LOC. It represents the name of the memory location, place A or where to. Just like in normally in our programming languages, we are making use of the variables we are using or identifiers what we are using. So these are nothing but the placeholders of memory locations, names associated with that memory locations. Then the names for the processor registers are generally, we have in every processor we have the registers R0, R1, R2 like that. We have Rn. So n number of general purpose registers will be there. Okay, so that registers we can use, and there are some registers in the IO subsystem. Okay, that is the input output subsystem. So the registers which are available in the IO subsystem is generally named it as data in and out status. These are the two important registers available in the IO subsystem. So if you write any instruction like this, for example, if you take this instruction R is loaded with the LOC. So the LOC which we are enclosing in the square braces. So this indicates that the contents of this LOC is transferred into this processor register R2. So if you want to transfer some memory location address, memory location value, or a variable value if you want to transfer to a register, so we are writing like this. Suppose I want to load the register R3 with the contents of the memory location which is named with an identifier. For example, A. A is a memory location which is identified in the main memory unit. For example, you have named a variable name or identifier name you gave as A. Then if you want to load the contents of A into this register R3, you can write the instruction like this. So this will transfer the contents of the memory location identified with this A with the processor register R3. So for example, if you take this another important example here, R4 is loaded with the contents of R2 plus contents of R3. That means this particular instruction is going to add the contents of both the processor registers R2 and R3 respectively, and the sum will be placed into R4 register. Okay, so this type of representation or notation is called it as register transfer notation. In short, we can call it as RTN. Okay, so we can use the register transfer notation. So that is the first type of notation we can use. Next, coming to the second type of notation, assembly language notation. So in assembly language notation, we are making use of this load and store instructions we are using. So we are using load and store. Okay, so now if you want to load the LOC value into the processor register R2. Here the value of LOC will be loaded into the processor register R2. So the LOC value is unchanged. By loading this LOC value into R2, LOC value is not changed, but R2 value is now changed with the value which we have in LOC. Okay, so previous value if we have any in R2 register, so that will be overwritten with the LOC value. So this is a assembly language notation. So this same thing you can write in register transfer notation as like this. Simply R2 implies here contents of LOC that we are to enclose in square braces. So both are equivalent. This is a register transfer notation and this is the assembly language notation. So please try to understand the two important notations what we are going to use now. So the load is a instruction here which is specifying the contents of the memory location has to be read, which is identified with LOC, and then it is loaded with the value of LOC into the processor register R2. So that means this load instruction is in turn issues a read control signal to a memory unit so that it will be load the contents of this LOC value, LOC variable or identifier value into the processor register. Similarly, if you take this another important instruction, so add R4 comma R2 comma R3. So here in this particular instruction, which is a assembly language instruction, so it will be adding this R2 and R3 register content values and the result will be stored in R4. So that means here R2 and R3 will act as a source operands and R4 will act it as a destination operand value. It is a destination operand and these will act it as a source operands. So the same instruction you can write in RTN register transfer notation like this. R4 is transferred with the contents of R2 plus contents of R3. So this is an equivalent instruction for this assembly language instruction in RTN. So in register transfer notation, so this is what we are writing an equivalent expression for this. So an instruction always specifies an operation to be performed. Instruction always specifies what operation we have to perform and what are the operands are involved in that particular operation. So this is what an example for an assembly language instruction. This is an example for a registered language transfer notation instruction. So the instruction always specifies what operation the processor has to do and what are the operands that particular instruction has to be performed. Fine. Now coming to this RISC and CISC instruction set. So nowadays the modern computer systems will follow these two different types of instruction set designs. So one is called it as a reduced instruction set computing. RISC stands for reduced instruction set computing and CISC stands for complex instruction set computing. So these are the two different types of approaches that are used by modern computers to design the instruction sets. So one popular approach is based on the premise that higher performance can be achieved if each instruction occupies exactly one word in memory. So this is very important point. We have to note it down. So the performance of a computer is also depends upon the instruction, what type of instruction set the computer is using. In earlier video, what we have discussed on performance, so we identified one of the important factor on which the performance of a computer depends is hardware and software. Okay, so what type of instruction set that particular computer is making use. So if a instruction occupies one word in the memory, then whenever if you want to fetch an instruction with one read operation, we can read that entire instruction. So that is the important approach what the modern computers will follow while we are designing the instruction set. And what are the operands? The operands which are needed to perform that particular operation, like arithmetic or logic operations, are specified by an instruction which are already available in the processor registers. So the operands are residing in the processor registers, and the instruction which we are specifying that will occupies only one word in the memory, then that particular type of instructions are generally called it as RISC instructions, reduced instruction set we can call it as, and it is the most popular approach for designing of the instruction set. Okay, so reduced instruction set computers we are calling it as, okay, RISC computers we are calling it as. So an alternative to this RISC approach is to make use of more complex instructions which may span more than one word of memory and which may requires more complicated operations. More than one read operation or write operation is involved whenever we want to fetch that particular instruction. So such type of instruction which we are calling it as a CISC instruction, so complex instruction set computers we are calling it as. So these are the two important types of instruction sets the modern computers can follow. And I hope you understood the difference between RISC and CISC. So where in RISC computing, we are making use of only one word we are using in the memory, so that every instruction will occupy single word only, and the operands will be specified in the processor registers. Whereas in complex instruction set computing, so we are provided that means the instruction is occupying more than one word. Okay, so that is you have to understand this difference. Fine. So now the reflection point. So there is one important question for you to make understand about what is the difference between RISC and CISC instructions. Okay, so please try to answer this question. Fine. So once you understand the difference between this RISC and CISC instructions, now I am introducing about what is the RISC instruction set. So the two important key features of this RISC instruction set are each instruction occupies a single word in the memory. This is one important point you have to understand in the RISC instruction set. So each instruction exactly occupies one single word in the memory. And another important key characteristic is that load and store architecture is used in this RISC. Load and store. Load and store architecture is used. So in which memory operands are accessed. Memory operands are accessed using load and store instructions. The memory operands are accessed using load and store instructions. Load is for reading. Okay, it will internally issues a read operation. Store internally issues a write operation. So the memory operands are generally accessed through load and store. So that is the reason this RISC instruction set follows load and store architecture. So memory operands are accessed only using this load and store instructions. And all operands involved in an arithmetic or logic operation must be either in the processor registers, or one of the operands may be explicitly specified within the instruction word itself. So the operands may be residing in the registers, processor registers, or you can explicitly specify one operand within the instruction word itself. So generally in a RISC instruction set, we are making use of load instruction and store instruction. So the load instruction will have the following syntax: load destination comma source. Okay, load destination comma source, or load processor register comma memory location. So any of this syntax we can follow for load instruction set. For example, if we want to perform this operation, C is stored with the content of A plus contents of B. So you want to add, and the summation value you want to store in C. So what we need here is that first we have to load the contents of A into register, processor register, because the operands must be either in processor registers, or the operand value must be specified within the instruction itself. That you have to clearly understand in the RISC instruction set. So first we will load the operand value A into the processor register, some R2, and the operand value B we are loading into the processor register R3. Then you will execute the add operation, add R4 comma R2 comma R3. So where this R2 content and R3 contents will be added, and the result will be stored in R4. Now if you want to store the result which is available in the processor register R4 into the memory word C, so then we will write the store instruction, store R4 comma C. So it will store, or it will write the contents of R4 register into the memory word named with C. So this is what the RISC instructions we are specifying to perform this operation. Okay. So now based on this concept, so this is the lecture level practice problem you have to solve now itself. So write the RISC style of instructions to perform the following operation. So X is loaded with the contents of A minus contents of B star contents of C. Now write the set of instructions in RISC style. That is nothing but you have to make use of load and store instructions, and the processor registers you have to use to processor registers we have to use to store these operand values. Fine. So this is the today's lecture, and the lecture outcomes are after completion of this session. So you must be able to represent the instructions in various notations like assembly language notation or the register transfer notation, and identify the steps in given instruction execution one at a time in order of increasing addresses. So how the instructions are going to be executed. Okay, so thank you one and all for listening to this session.